All right, good people. So we are on reflection, and the important notes to take is on reflection. When you join the corresponding points, you get parallel lines which are not equal in length. So it's now different from translation. Translation, if you join corresponding points, you get parallel lines which are equal in length. But here on reflection, if you join corresponding points, you get parallel lines which are not equal in length. Then another important point is image and pre-image, they share the same distance from the invariant line. All right. So we ask you to describe the single transformation that maps triangle ABC onto triangle A1, B1, C1. Okay. So first thing is first, let's join our corresponding points. Let's join A and A1. A and 1. So I'm drawing some broken lines here. A and what? And A1. Then B and B1 and C and C1. They are in what? In a single straight line. So we are joining our corresponding points. Okay. So as we can see, we are getting parallel lines. Parallel lines, they are all parallel lines, right? Here C and C1, B and B1, A and A1. They are parallel, but they're not equal length. For example, A and A1, then C and C1, they are not equal length, yet they are parallel. So the only way is the only transformation that if you join corresponding points and you get parallel lines which are not equal length is reflection. So we're going to write here reflection. So another thing is to find the mirror line or the invariant line. So on invariant line, remember I mentioned earlier on that if you get corresponding points, you get parallel lines which are not equal length. So image and pre-image, they share the same distance from the invariant line. Our pre-image here and image, they share the same distance from the mirror line. Okay, so we can count here from A to A1. How many boxes do we have? 1, 2, 3, 4, 5, 6, 7, 8. And 8 divided by 2. So these two, they share the same what? The same distance from the invariant line. So 1, 2, 3, 4. That's the midpoint. Then C to C1. 1, 2, 3, 4. So the midpoint is 2, 1, 2. So it's right here. So meaning to say, this line right here is our mirror line or our invariant line. This one is our mirror line. So meaning to say, if you take B to this mirror line, and if you take B1 to this mirror line, you still get the same one, the same distance. For example, 1, 2, 3, 4, you're getting 4 lines. Then 1, 2, 3, 4, you're getting what? 4 lines. Which means to say this pre-image to this invariant line and this image to this invariant line, they are sharing the same one, the same distance. So it means it is what? Reflection. So it's what? In which line? This line is cutting through our x-axis. So x is equals to 1. So in the line is reflection. In the line, what? Equation of a line is what? X is equals to what? X is equals to 1. That's the mirror line. Okay, so let's say you're asked to find, let's say they say triangle A1, B1, C1 was mapped onto triangle what? Onto triangle A2, B2, C2. In the line y is equals to 0. Let's say this is our mirror line, the x-axis, right? So we want to reflect triangle A1, B1, C1 through this mirror. So let's count. Remember, image and pre-image, they share the same distance from the invariant line. So we're going to count from A1 to the invariant line. There are many boxes here. 1, 2, 3. Okay? So remember, image and pre-image, they share the same distance from the invariant line. So we're going to count another 3 boxes from our mirror line. 1, 2, 3. That's right here. So that's where there is what? A2. Let's take B to the invariant line. How many boxes here? 1. So they share the same distance. We're going to count one box to this point. So it's what? This one is B what? B2. Let's take C1 to the invariant line. How many boxes here? One. So we're going to count another one box to this side, and we'll get what? A2. Okay. So let's draw our shape right here. So we are going to draw our shapes right here. Oh, this one is what? This one is C, is C2. So let's join our triangle. Our triangle. Okay. Right here. Okay. So as you can see, we still got somewhat some congruent shapes. They are still equal. So when we join our corresponding points C and C1, B and B1, you get parallel lines which are not equal in length. So that's reflection. And on reflection, you should always treat that image and pre-image, they share the same distance from the invariant line. And another important note, if you join corresponding points, you will get parallel lines which are not equal in length. And image and pre-image, they meet at 90 degrees on the invariant line. So that's our reflection, and thank you for watching.